In this video, we're going to cover section 5-5, applying systems of linear equations. So now everything you've learned in this chapter is culminating into this area where we need to apply it. So first we're going to look at identifying which is the best method, and then we're just going to look at applying it to the scary thing of word problems. So first, just some backtracking. We have these different methods of solving. We have graphing, substitution, elimination, using addition, subtraction, and multiplication. So they all go hand in hand, but some are easier than others. Graphing is the one we usually want to try to get away from just because it can be inaccurate. Substitution and elimination, it all depends on what you're given. So determine the best method to solve the system of equations. So looking at this one, 5x plus 7y is equal to 2, and negative 2x plus 7y is equal to 9. So as I look at this, I go, wait a minute, 7y's and 7y are the exact same. So if it's already set up for that they're the same, I would just say, well, elimination is the best method. Because all I have to do to the two equations is subtract them. So if I subtract, I get 5x minus negative 2x is 7x. The y's cancel out, and I'm left with negative 7 on the right side, 2 minus 9. Divide by 7, so x is equal to negative 1. I'm going to plug it back in somewhere. It doesn't really matter where, as long as it's for the x. I'm going to plug it in right there. Negative 2 times negative 1 plus 7y is equal to 9. 2 plus 7y is equal to 9. Subtract 2, 7y equals 7. Divide by 7. So y is equal to 1. So final answer is negative 1, 1. So now we're just learning to identify which one is going to be the most useful to us. And you'll have a couple of chances in the homework to practice this. Next, we're going to look at some word problems. At a sale, Sarah bought 4 t-shirts and 3 pairs of jeans for $181. Jenna bought 1 t-shirt and 2 pair of jeans for $94. The t-shirts were all the same price and the jeans were all the same price. So the following systems of equation represents the situation. Determine the best method to solve and then solve the system. So if we look at this, they do have it already set up for us. I'm just move it over just a little bit. So now, both substitution and elimination would take one step more. So it really doesn't matter which one you do. I prefer elimination when I can. So in order to do this, I would have to multiply the bottom one by 4. And that would give me 4x plus 8y is equal to, we got to do a little math in our head. Let's just do a little scratch work here. Just so we don't make any mistakes. Carry the 1. 4 times 9 is 36, so I get 376. Okay, so there we go. So we don't need our scratch work. So now I am looking at this. So for these equations, all I have to do is subtract them. So 4x minus 4x, they cancel out. 3y minus 8y is 5y, negative 5y, sorry. And 181 minus 376. So I'm going to apply my adding the opposite abilities. So 376 is smaller, so my answer will be negative. So all I have to do is subtract the 2. So I get 5, need to borrow. So I get 9. So I get negative 195. And then from there, simply do a little arithmetic. Divide by negative 5. Divide by negative 5. So y is equal to, looks like it is, 195. Just doing a little math here. I could grab my calculator, but I'm not going to. I'm just practicing my arithmetic skills. So y is equal to 39. So it looks like since y is matched up with jeans, it appears jeans cost $39 a piece. So now I'm going to plug that back in. And I already have a good equation to do that with. So 39, and I'm going to go right back to the 2y. So I get x plus 2 times 39 equals 94. So x is equal to, not equal, sorry about that, jumped ahead, plus 78 is equal to 94. Subtract 78 from 94, and I get x is equal to 16. So x represents the price of shirts, so shirts would cost $16. So $16 for the t-shirts, $39 for the jeans. Let's write that in. T-shirt, jeans. Just so we know. Okay, so there we go. So now to know, Jared has volunteered 50 hours and plans to continue volunteering 3 hours each week. Clementine just started volunteering 5 hours each week. Find the number of weeks in which Jared and Clementine will have to both volunteer the same number of hours. So they're not giving us the equation, so I'm going to say x represents the weeks and y represents the hours. That helps us organize. So Jared has y hours. He has already done 50, and he plans to do 3 hours per week. So when we say per, we're multiplying, okay? So per week, okay? And then Clementine, he wants a total of 50 hours, or not 50 hours, but y hours. And he doesn't have any hours, so 0 hours already, but he's doing 5 hours per week. So now this one, we could try to do elimination, or we could do substitution. I'm going to do substitution in this case. I'm going to take that 5x and I'm going to plug it into the y on the other one. I'm going to use substitution. So now I just have 5x is equal to 50 plus 3x. And I'm right back to basic algebra. Subtract the 3x from both sides. So I get 2x is equal to 25. Oh, I don't know why I'm jumping ahead of myself. You guys know why. You can already see it, I hope. Is equal to 50. Divide by 2. So x is equal to 25. And x represented the number of weeks, and that's what I was really looking for. So I'm done. So it would take 25 weeks for them to have the exact same number of volunteer hours.